ATVs are a lot of fun. They have plenty of torque and are also very fast. But after riding it for about 2 years, I was starting to wonder if I can make this thing fully automatic. So in the beginning, it'll start with first gear, giving us the best torque, and shift higher automatically as it speeds up. If you're new to the channel, then make sure to hit that subscribe button. All main components will be linked in the description, and let's get started. Now you might be saying that such ATVs already exist which have a continuous variable transmission. But the problem with those is that you can only tune it to either give you a lot of torque, but becomes a gas guzzler and is very loud, or it can be set to run quiet with little fuel and has less torque. But you can't easily change this whenever you want. However, with the standard transmission where you shift with your foot, you have the option of shifting up at either high RPMs, giving you faster 0 to 60s, or shifting at lower RPMs not to bother the neighbors and save some gas money. To be able to shift up or down without using my foot, we are going to use an air-powered cylinder. These things are quite inexpensive, costing less than 20 bucks, and are also straightforward to control by hooking up a solenoid valve. After we hook up an air compressor, by pressing the manual trigger button on the side, we can see how it extends all the way, and as soon as we let go, it returns to its original position. Probably the most practical place to put it would probably be to put it somewhere here and I guess come out with metal from the bottom for the cylinder and then run up from the top to somewhere on the frame. But then there would be another issue that we're very close to the exhaust. Exhaust is right there, and if we put the cylinder right next to it, it can potentially melt the seals in the piston, and we don't want that. Another way we can do this is by putting it somewhere up here and welding the top to this piece of metal, and then the bottom can be linked with some kind of a rod. So this part I can have a piece of steel somehow connecting to the shifter, and that should probably work. That should probably be the best way because the piston is not in the way. It's up here, and I'll leave enough clearance for my foot to be able to go here, slide under, over, under. So yeah, that should work. I had some threaded rod laying around, and I put them together with some nuts to make one long steel rod. I was thinking about this for a while, and the best option where the rod should be mounted is threaded into the bottom end of the cylinder. But this cylinder didn't come with threads, so I'll have to make my own. Alright, it looks long enough, but it's still a little flimsy, so I think we should weld them together. Now that the rod is one solid piece, we don't have to worry about it falling apart. We can also have a look at how we're going to connect it to this shifter. The rod won't stay in one position, it will constantly move back and forth. So for that, I found a smooth piece of steel rod, which I'll pack in with some nuts and washers. It also comes with a threaded hole, which I'll use to keep everything in place. If we weld the nuts in pairs, we now have a simple joint. I'll also weld on a piece of steel, which will later be welded to the shifter. Now for the top part of the cylinder, the joint will be a little bit simpler because it already comes with a little pin, which I can then put on a little nut, which has a very tight tolerance. To that nut, I'll weld another 2, which will allow the joint to have more angular freedom. Here you can see that it swings left and right and doesn't bottom out. I think it's looking good, so time to weld the cylinder in place. We want half of the stroke from the piston to push it up, while the other half will push it down. I'll measure the distance between the cylinder and the frame so I can start cutting some steel to create a bracket. Now to construct this, I'll use some flat steel bar since it is relatively cheap and adds just enough support without adding a ton of weight. I'll remove the paint from the metal in the places where I want to weld. I'll also cut another piece of steel for more support. At this point, we can weld the bottom part of the rod onto the shifter. And just like that, everything looks solid, so I think we are ready to test this thing. Let's hook up the solenoid valve. Whoa, easy tiger. Well, it seems to be working just as we intended. Next up, we are going to install the compressor. For now, I'll use a battery-powered portable Ryobi compressor to keep the project simple, but I might eventually upgrade to a waterproof compressor specifically designed for vehicles and can also be powered from the onboard 12-volt battery. Because I want to keep it simple, I'll just mount the compressor using a ratchet strap. This ain't going nowhere. Next, we're going to mount the solenoid valve to the plastic fender so the cylinder shouldn't have to lift any extra weight. I'll add some blue Loctite, which will prevent it from becoming loose while still letting me remove it, unlike super glue. If you remember how the test went, as soon as we supplied it with air, the cylinder went up, and as soon as we pressed the button, the cylinder went down. But we want the shifter to stay in the center and also be able to control the upshifts as well as the downshifts. So for that, I got myself a second solenoid valve, and I'll close off port 8 so it will only move the cylinder when you press the button. Now I'll cut up some 1/4-inch polyurethane tubing to connect the valves to the cylinder. And I made sure to cut plenty so the tubing shouldn't kink. Nice and solid. I'll plumb up both solenoid valves with some elbows. Merge the tubing into splitters. And then hook that up to the compressor using an elbow. Time to test it out. The top solenoid valve controls the upshifts while the bottom one controls the downshifts. While it might look and sound amazing, I didn't like the fact that the cylinder gets bottomed out at both the upshifts and the downshifts. So to fix this, I got myself a cylinder with a 50% larger stroke size. This is you, and this is the guy she told you not to worry about. Because this one is longer, I had to bend up the mounting bracket and also cut off some of the rod. We can then tighten down the threaded rod and also secure the cylinder rod in place. Before we test this thing out, I'll go ahead and add more reinforcement to the bracket because I've noticed in the previous test that the top part was bending a little from the cylinder's force. And just like that, this piece of art is complete. And we now also have way more available movement when shifting. This thing is also so powerful that it's tilting the entire front frame. But I digress. Let's see how well it'll shift when driving the ATV. Just like that, it's able to shift pretty smoothly. that it didn't skip any gears. But what if we put the pedal to the metal and give it full throttle? Will it be able to handle that? Let's find out. Once again, I'm blown away and it didn't skip a single shift. If you made it till here, you might be saying that this is not considered shifting automatically, and I still have to use my fingers to turn on the solenoid valves individually. So in the next video, I'm going to put together some electronics which will do just that. If you found this video interesting, then hit that like button because it can help this video reach more viewers like you. And consider supporting me through Patreon so I can keep creating more videos. And I will see you guys in the next video.